Okay, so let's kind of look at the pattern that we found here. And again, you could do Pythagorean Theorem, but this was that 3, 4, 5 that we discovered earlier. So like 3 and 4, 3 squared plus 4 squared is 9 plus 16, which is 25. So if a squared plus b squared equals c squared, then I know that c squared is 25, and the square root of that is 5. So I get this guy. So notice that, how does that relate to the other one? So what relationship do you see between the others? And so if you look, you're like, oh, I could scale these all up. So if I multiply this by 2 and 2 and 2, I get 6 and I get 8, so this must be 10. So then how could I scale them up to get the next one? Well, times 3 would be 9. Times 3 would be 12, so times 3 by 15. So once you know one Pythagorean triple, you can come up with infinite many more. Multiply everything by 10, so this must be 50. Let's see, what do they multiply? But we hit this one by, is that 19, I think? Maybe multiply this by 19, that by 19, and 5 by 19 is probably how they came up with that 95. So you can multiply by 17, 19, whatever you want. And then here, I could either go to the start and multiply those all by, what, 20? But I could also take this row and multiply them all by 10 and get that. So again, the relationship is that they're all just scaled up of that original Pythagorean triple. All right, so looking at that, here is a Pythagorean triple, so I'm guaranteeing that works. And we can test it if you're like, you know, Julie, are you sure? Well, all right, I have longest side has to be the hypotenuse, so that's 13, and then I have 12, and then I have 5. So let's try Pythagorean theorem. So 5 squared is 25. That's your a squared or b squared. This guy, 12 squared is what, 144. And if I add those together, I get 169. And if I square root that, I get 13, which is what that is. So again, remember the area of this guy, the area of that guy has to add up to the area of that guy, and it really does work. So try to find 2 more triples that are like in that family, and then go ahead and try to do that down there. Okay, so if I know this is a Pythagorean triple, I can scale it by whatever I want. So if I want to scale it by 2, I can make all of them 2 times bigger. So what is that? 10, 24, and 26, and that has to work in Pythagorean theorem. I could make them all 10 times bigger, so scale them by 10. So 50, 120, and 130 would have to work if I shoved it into Pythagorean theorem. All right, let's look at B. Complete the following triples. So you know these are Pythagorean triples, which means they have to work in Pythagorean theorem. So again, this is going to be your A, your B, and then go ahead and solve for C. So I'll give you another minute if you weren't quite sure what to do there. Okay, so if this is my A and my B, so 8 times 8 is 64, or 8 squared. 15 times 15 is 225. And I'm trying to figure out c squared. So if I add those together, what is that? Is that 289 equals c squared? And again, there's the only math to undo my variables on one side, numbers on the other. There's no add or subtract, but there's square root. So to undo square root, I need to square root. And so if I square root, it looks like I'm going to get that c equals 17. Let's see, make sure I'm good here. So, all right, so that's that one. Okay, for the second one down here, 14 squared and 48 squared. So on your calculator, go ahead and type that in, get the area. Type that in, get the area. And then your goal is to find c squared. So you numbers and numbers, you can go ahead and add. So see what you get when you add those together. And then once you get that number, you're going to get some value here equals to c squared. So again, the only math to do is to undo the c squared. So you're going to square root both sides. And so see what you get for that number. When you square root it, you should get 50 for an answer. Okay, so 50 for an answer. So this, after you add, you should have gotten 2,500. And so then when you square rooted that to both sides, you should have ended up getting 50 for C. All right, let's look at example 2. Now notice there is a video for this one. So see that link. So you could go ahead and watch that video online if you would like. But let's look at this. A lot of times to tell if something is square, you can't really use a protractor. So like when my dad built our deck, he put, like if this was our house, he put a lot of pegs here, 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 and we had a lot of string all over the place. So he would have string, and what he'd do is he would measure the diagonal. And he knew that if the math worked out, that if this side and did Pythagorean theorem and did this side, then he knew he had it square. If he did Pythagorean theorem and it did not equal the string length here, then he knew that he messed up. Okay, so we have kind of that situation here. Now some people are like, whoa, wait a second, we have a 7, we have a 2, and then we have a 25. All right, so the 2 is 2 feet. So again, your units have to match if we're going to do math. So 2 times 12 would be 24 inches. So that makes a huge difference. All right, so again, this has to be your longest side. All right, so Pythagorean theorem. And we're just trying to see if this is really a right angle. Like, is this really square? And you know if Pythagorean theorem works, it is. So 7 times 7, 7 squared is 49. 24 times 24, I do not have a calculator with me. And then 25 times 25, that one I have memorized, that's what, 625? All right, so I'm going to pause this and multiply this by hand since I don't have a calculator on me, and then we'll pick back up to see if this is really square or not. Okay, so I did a little scratch work to the side, but again, if you have a calculator, that's great. So 7 times 7 is this, 24 times 24 is this. If I add that up, that does equal 625. Which is what 5 squared is. So I know because the left side balances with the right side that that is a right angle. So this person knows that they have a 90-degree angle in there. All right, let's see. Let's go ahead and try number 5, and then I'll pick up there. Okay, so in this one, if you're struggling with a little bit, you got to kind of visualize what's happening is there's kind of a lip, I guess, so to speak, and so we want a ramp that's going to go like this. So if you think of it from a 3D perspective, can you kind of see this as the ramp? So we want to get up and then have the ramp kind of go like this, okay? So again, if it was on a building, we would want it to connect. If it's a skateboard ramp, we might just be, going off the edge there. So see if that picture helps you. Try to find what numbers go where so that we can solve this problem. Okay, so hopefully you could figure out what's kind of going on here. We want it 2 feet off the ground, so that would be this, right, when you, go off of it. The plywood is 4 by 8, so we want the long side, the longest ramp possible, so 4 by 8. And then we want to know the length of the frame that's going to sit on the ground. So what's going to happen is they're going to obviously make some wood frames out of some wood, and then they will nail in the plywood on top and probably put some support underneath. So I want to know how long does this frame piece have to be right there. So hopefully you can see that you have a right triangle right in there. So we're going to do Pythagorean theorem to figure out that frame piece. So Pythagorean theorem is a squared plus b squared equals c squared. Again, it's all about area. So the area on that, 2 by 2 would be 4. So 2 squared is 4. B, I don't know. That's not the hypotenuse. This is the slanted longest side. This is not B. So, or it is B, but I don't know what it is. So that's B. Hypotenuse is the longest side. It's across from your right angle. So 8 squared, which is an area of 64. So if I made a big square that was 8 by 8, it would have 64 squares in it. All right. So again, if you're like, I've never seen this type of equation before, it doesn't matter. What's going on here. In real life, if you knew what B was, you would square first, and then after you got that done, you would add the 4. So we are doing order of op backwards to solve it. So to get rid of adding 4, we're going to subtract 4. I'm going to come over here. So I get B squared equals 60. All right, and then the only thing I have to get rid of is square rooting, so the reverse of that is square rooting. And again, remember, normally you get 2 answers, but because we're dealing with real life and distances, we're not. So the exact answer is that B equals exactly the square root of 60. But if we kind of want to make it, so if you approximate that, it's about 7.7 feet. Now, if you know anyone that builds, they're probably not super happy with that answer. So they're going to want it in feet and inches. So the 7 part is great. So the 7 part is I definitely have 7 feet. So I have 7 feet. But what about this 0.7 feet? So what I'm going to do is I am going to take that 0.7 feet and I'm going to multiply by 12 inches per foot to figure out how many inches that is, because someone who does woodworking, they're going to care more about that. All right, and I don't know what happened there. Okay, so if I take 0.7 feet times 12 inches, I get about 8.4 inches. So if I'm building this, I know that it's 7 feet plus an additional about 8.4 inches, and that would be that distance of that bottom frame. All right, I am going to stop there. On your homework in your book, just a quick hint here. Let me just erase some space. On problem number 3, B and C, when you draw those triangles that fit in that space, so if this is your grid paper, your triangles are going to go like kind of like this. Sometimes students draw random triangles in the middle, but this is 0, 0, and you're going to plot like the width and length, or like A and B, and then this distance actually will end up being your hypotenuse. But so you're going to plot the, I don't know, shorter leg on this side, and wherever it is, longer leg on this side, and you're going to make triangles that kind of look like that. So that might help you with problem number 3. All right, we're going to stop here, and then I'll work on the next section.